Hello, and welcome to another project walkthrough video. In this video, we're going to work on using collaborative filtering to figure out which books you might like, and then we'll build personalized recommendations for you using data from Goodreads. If you're not familiar with Goodreads, it is a site where a lot of people review books and share their reading activity. But whether you have a Goodreads profile or not, you'll still be able to use this walkthrough to get personalized book recommendations using collaborative filtering. So let's dive in and talk a little bit about what the project is going to look like. So this is a bit of a complex project, so I'm going to go through a few slides just so you can see what is involved and what the steps of the project will be. So the overview of the project is here. So we will be working to get personalized book recommendations. And to do that, we're going to look through some data we have to find users who have similar tastes in books to us. Then using that, we're going to find what books they like, and we're going to find a way to rank those books and recommend them. So we will end up with a list of recommendations of books that we might like. So that's the overview. And as I mentioned, we'll be using book data from Goodreads. That data was scraped by researchers at UCSD, and it's available at this URL. I'll include links to the datasets in the video description, so you can go ahead and easily download them. There are three main data files we're going to use, and I'll walk through them very quickly. So the first file we'll use is called goodreadsinteractions.csv. So this has three columns that we care about. It has user ID, book ID, and rating. And essentially what this dataset does is for every user, it has what books they read and how they rated those books. So it gives you a full history of how a user has rated different books on Goodreads. The other file is called bookstitles.json. So for every book, this has the title of the book, the URL on Goodreads, the URL to the cover image, as well as how many ratings it's received on Goodreads. So this file essentially has information on each book. Then to unite these files, we use a third file called bookidmap.csv. Basically, this file has a bunch of rows, and each row contains the ID in the Goodreads interaction CSV file, and then the corresponding ID in the book titles JSON file. So this helps us unite the two files and combine the book title data with the interaction data. All right, so at a really high level, we'll take three steps in this project. We'll find users who are similar to us in terms of their tastes in books. We'll create a matrix to represent all of those users in the books they've read. Then we'll build a book recommendation engine using that matrix to find users who are similar to us. All right, that said, let's go ahead and dive in and start coding. So I'm using Jupyter Lab, which you are hopefully familiar with, and I'm using Python 3.9, and I'll be using a few packages like pandas as well. So the first thing I'll do is I'll go ahead and import pandas as PD, and I'm going to go ahead and import a file that I didn't talk about, but you can either create your own file or download it. So it's likedbooks.csv. So this file contains which books you liked. So there are three columns that are really important: user ID, book ID, and rating. And in the previous video in this series, I walked you through how to search for books and then create a list of books that you liked. So you can either download this file, I'll link the URL in the description, or you can create your own file that contains books that you like specifically. So now that I introduced that file, let me go ahead and jump back into coding. So the first thing I'll do is I'll go ahead and read that file in. Read CSV, likedbooks.csv, and then the index column is column 0. So that's just the row index numbers. So let's go ahead and run this and take a look. Liked books, right. Mine is called liked books full because it has all of the books I liked. If you download the file liked books, you'll just get a slightly different file, but don't worry too much about full or about the liked books full versus the liked books. You'll probably just have that. So as I mentioned, you can either create your own file here, And then these three columns are the important ones, or you can just use the sample file I've provided. Either way, you should end up with a data frame that looks like this, that has three columns: user ID, book ID, and rating. All right, so one thing we want to really be careful about is we want to make sure book ID is a string, because that's how we'll match it with book IDs in the other files. So let's just make sure we convert it to a string type using the pandas as type method. So that's now ensuring it's a string. So the next thing we'll do is we need to figure out the users that are similar to us in the Goodreads interactions data. And in order to do that, we first need to load in the mapping file. So I showed you that file that maps between the IDs in the JSON file and the CSV file. So let's go ahead and open that file, bookidmap.csv. We'll open that in read mode as F. And we did this technique in the previous video, but the idea is we want to read this file line by line, not read it all in at once, because this is a fairly large file. So what this will do is this will loop over every line in the file and read it one by one. And once it's done reading, it'll just end the loop. That's what this if statement does. All right, so we say CSV ID book ID is line.strip.split on the column. So what this does is every line in the file, actually I'll just show you the file. Book ID map, CSV. The exclamation mark in Jupyter Lab, it just runs something on the command line. So this is the book ID map file, the first few lines. And you can see each line is just the CSV book ID with a comma and then the JSON book ID. So when we split the line on a comma, we end up with these two variables, the CSV ID and the book ID. And then we'll just assign these to the dictionary. And the strip here just removes the new line character at the end of the line. So we don't get a hidden new line character here, we just get the book ID. So I'll go ahead and run that, and we'll end up with a dictionary that helps us map between the IDs in different files. All right, now we'll create a set that contains all of the unique books that we have read. So a set is kind of like a list in Python, except each element is unique. So each element in this set is unique. An element can't be in a set more than once. And this set just ensures that we can easily look for users who have read the same books as us. And we'll store any user who's read the same book as us in this overlap users dictionary. So let's go ahead and open our interactions file. Actually, before I do that, let's actually just take a look at the first few lines of the interactions file, in case you missed the previous part and have not seen it yet. So you can see, similar to how I showed you in the presentation, we have a few columns. The columns that we care about are user ID, book ID, and rating. And you can see each line is just a comma-separated list of those values. So we'll use the same technique from above to read it one by one. Let's actually take a look at the number of lines in this file. So this file has quite a few lines. It has 228 million lines, and the file is about 4 gigabytes. So we could read that into memory if we have a lot of RAM, but if you read a 4 gigabyte file into memory and work on it in pandas, you're going to be doing a lot of copying operations on it as you work with it. So you could end up using 20 plus gigabytes of RAM, and not everyone has that much RAM on their system. So we're instead working with the file line by line. Instead of reading it all into memory at once, we're actually working with it in streaming fashion. So that's what these lines of code are doing. So we'll do the same thing we did before. Underscore just means that we don't really care about that variable. So we'll just, again, split up the line on the comma and assign it out to these variables. And then we have the CSV ID, but we want to get the book ID. So we'll just consult our dictionary to get the right ID here. And then what we'll say is, hey, if this is one of the books that we've read, so if this was in our liked books data frame, so if this is one of the books that we have read, then let us add this user to our overlap users dictionary. And we're actually keeping count of how many times a given user has books that overlap with the books we like. So at the end of this loop, which I'll start running now, overlap users will be a dictionary. The keys will be user IDs, and the values will be the number of times that user has read a book that we liked, that we also had in our list of books. We didn't like all the books. You'll notice I rated some of these a 1, so 1 out of 5. But basically it's telling us, did this user actually have some overlap with us in terms of books? Did they read the same books as us? Users that don't overlap with us will probably not be great for actually making any predictions or anything like that, because I forgot to put this in the loop. So let's go ahead and do that. ID. Okay. Using .get here just prevents an issue where the header row cannot actually be found in the dictionary. So it just skips that. .get returns none if it can't find the value, versus if you use the bracket notation for a dictionary, it just it throws an error when it can't actually get the value from the dictionary. So this will return and give us a dictionary. And once it does return, we can look at the length of that dictionary using this code. This is still running, so this won't run just yet. And then once it finishes running, what we can do is we only want to find users who have read some of the same books as us. Because as I mentioned, users who haven't read any of the same books as us won't be useful for predictive purposes. Because we need to figure out, okay, we overlapped with this person on some books, therefore we will likely like the same books as them. So what we're going to do is we're going to say, unless a user has read a certain number of books and they are in common with us, we'll just take them out of our list of overlapping users. So what we'll do here is a list comprehension, k for k in overlap users, if the value, so the number of books they have read that overlap with us, is at least 20% of our total book count. So in this case, I rated 533 books. So this will look for people who have a little more than 100 books in common with us. I hope that makes sense. The reason we do this is we want to cut down on the number of users that we're building a matrix for and doing some computationally intensive stuff later on. So filtering just helps us reduce the number of users that we have to compare our own books against to get recommendations. So that's why we're doing the filtering. So let's run that. And then once we have this smaller set of users, we'll build something called an interactions list. And this list will just grab user ID, book ID, and rating for all of these users. And we'll use this to generate our recommendations with collaborative filtering in just a second. So we'll again just loop through. So while true, read the lines in. And what we'll again do is split based on the comma. All right. And then what we'll say is, hey, if the user is someone in our list of users who have overlapped with the books we've read, then let's add the reading history into this interactions list. All right. And then what we'll say is interactions list dot append user ID, book ID, rating. All right. So what we'll end up with is for every user who has read some of the same books that we've read, at least 20% overlap, we will create a list of all the books they've read, because those are probably the books that we will like to read, right? The same books that users who read the same books as us also read. All right. So the next thing we need to do is build a collaborative filtering matrix. So let me jump back to the presentation and talk a little bit about that and what that looks like. So what we're going to build is a user book matrix. So every row of the matrix will be a different user, and every column of the matrix will be a different book. And the cells in the matrix will contain the rating that that user gave to that book. So you might be able to see if we have a lot of users and a lot of books, this matrix can rapidly become huge, which is why we filtered down our user list. All right, let me jump back to code and we'll get started actually building this matrix once things finish running, because this will take a while to finish. Okay, now that our code is finished running, we can go ahead and take the next steps with building that user book matrix. All right, so the first thing we'll do is we'll see, okay, how long is our interactions list? All right, so you can see we filtered down from 238 million rows to about 2 million rows, which is still a lot of rows, but a good amount of filtering here. And then let's take a look at the first item in this list. So you can see it's a user ID, a book ID, and the rating they gave to that book. So let's go ahead and turn this into a data frame. Interactions list. So you can use the DataFrame constructor to initialize a data frame using a list as input. And our columns will be user ID, book ID, and rating. All right, so let's go ahead and run that. And then what we'll actually do is add our own ratings into this matrix. And to do that, we'll use the pandas concatenation function. So we'll concatenate my books, which you saw before, was our ratings for different books. Or my ratings if you downloaded the file I linked to. And we'll concatenate that with the interactions file. So what this does is just put our ratings into the ratings with everyone else. So when we create that matrix, our ratings will also be a row in that matrix, in that user book matrix. So let's take a look at interactions. So we can see our user ID is -1. So the first few rows of the matrix are all our ratings. And there are other people's ratings as well. These are people who read the same books as us. So in this data is what we need to generate our recommendations. All right, so there are a few things we have to do before we go ahead and create that user book matrix. So let's go ahead and just make sure things are the right data type. Always good to do. We want these book IDs and user IDs to be strings, because that's how they're stored in the JSON files. And we want to make sure we can align things properly when we work across files. So let's make sure these are strings. And then our ratings are going to be numbered. And we can use the pandas toNumeric function to actually convert the ratings to numbers. These ratings are 0 through 5, so they're all numeric data. All right. So the next thing we need to do is right now our user IDs, let's actually look at this. Let's look at the unique values. Our user IDs look like this. They are really long numbers, but we want each user ID to correspond to a single row in a matrix. So what we're going to do is we're going to convert these and basically assign 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to each of these IDs. So we'll create a column called user index. And the thing we'll do is we'll say interactions user ID dot as type category. So what category does is all numbers that are the same in the data set, it basically converts to the same category. So here it would split each unique user ID up into its own category. And then when you grab the category code, it'll basically assign a number 0, 1, 2, 3, 4, 5, 6, 7 to each row. So I'll show you what I'm talking about. So if we look at the first row, we can see the user index is now 0 for user ID -1. If we look at the 200th row, still the same user, we can see the user index is a number that corresponds to the user ID, but it's in order. So it's 0, 1, 2, 3, 4, 5, 6, 7, etc. Let's take a look at user index. We can look at the unique values in this column. So you can see it is sequential numbers. So 0, 1, 2, 3, 4, 5, 6, 7, etc. Which means you can assign these to a row in a matrix. So row 0 in the matrix is user ID -1. Row 1 is, I can't match these up visually, but hopefully you get the gist. We'll do the same thing with the book ID. Book ID dot as type category dot cat dot codes. Okay, now I'm going to talk a little bit about the structure of this book matrix, user book matrix. So let me jump back to my slides. So here is a little bit closer look at converting the ID to a position. We essentially just mapped a position to each user ID. And we did the same thing with each book ID. So we know row 0, column 2 in the matrix corresponds to a given user ID and book ID. When we construct our matrix, we're going to use something called a sparse matrix. And the reason why is we have, actually let me jump back to the code so you can see exactly how many we have. But let's count up how many unique books and users we have. So let's see, interactions book index dot unique. So we have 607,000 books. And if you look at this, we have about 129 unique users. So if you multiply those out, that gives you this many unique matrix cells, 78 million. So if you were to store all of that on disk in a dense matrix, where you actually put a value in each of those 78 million cells, it would take a huge amount of memory. Instead, we're going to do something called a sparse matrix. A sparse matrix is a little bit harder to work with than a dense matrix. The benefit of a sparse matrix is if there is no value in that column, you just leave it blank. It doesn't take up any memory or storage space. So typically when you're working in pandas and numpy, we're actually working with dense matrices and dense arrays. So we're going to create a sparse matrix in order to save memory. And creating it is a little bit different than creating a numpy array or a pandas data frame, but it saves us memory, which is really important because we kind of need it, or we might run out when we create our matrix. All right, so let me show you how to do that. Let's jump back to our notebook. Okay, so we're going to use scipy, which you may not have used directly at this point, but is a really interesting complement to numpy that does a lot of scientific Python things. We're going to import something called a COO matrix. So this is a type of sparse matrix. And what we'll do is we'll create this COO matrix. And to create a COO matrix, you pass in first an array or list of the data you want in the cells, in this case, the ratings. Then you pass in the row positions, which is user index. Those are the row positions of each cell. And then you pass in the column positions. All right, so that should do it. That will create our COO matrix. So you can see this is 129 rows and 607,000 column sparse matrix. And it's only storing 2.3 million elements. So instead of all 78 million cells having values in them, only 2.3 million cells do, which saves us a lot of memory. So we won't keep this in COO format because a lot of the utilities that we need to run only work with matrices, sparse matrices in CSR format. So I wouldn't worry too much about the formats. They just really indicate how data is stored under the hood and the data model, but you don't need to worry too much about that at the moment. All you need to know is we're going to convert our COO matrix to a CSR matrix. COO matrices are a little bit easier to create, which is why we initially created it in COO format. And now we're going to convert it to CSR format. All right, so we can find the row position of our specific user, and our user ID was -1 in our preferences file. So that matches to user index 0. So row 0 in the matrix is what we'll set to my index. Next, we're going to have to find users who are similar to us. So they have similar taste in books. And what we'll do is we'll use a cosine similarity measure to do that. So what we can do is, let's say this is, position 0 is a book, column 0 is a book, column 1 is a book, column 2 is a book, and each row is a user. So let's say this user has read the books in columns 1 and 2 and has rated them. This user has read none of the books. This last user has read all of them. And let's say this is us. This is our rating for the same books. So this user in the last row is who is most similar to us in terms of tastes, just based on the books we read and how we rated them. So we're going to use a metric called cosine similarity to quantify how similar each user is to us. And then we're going to find the most similar users and basically get their recommendations for what books we should read, which is why this is called collaborative filtering. We're collaborating with other people in our data. All right, so let's jump back. And what we'll do here is we just set my index. So we are row 0 in that matrix is our book ratings. And what we'll do is we'll import cosine similarity. So cosine similarity will just find the similarity between two rows in our matrix. So it can find how similar each user is to us in terms of what books they read and how they rated them. All right, so we'll say take my own taste in books and then figure out how similar each other user is to that. And then we'll call flatten to turn this into a numpy array. Cosine similarity. Missed the similarity part and missed running that cell. All right, cool. So we now have similarities. So we can see how similar we are to ourselves by looking at the first element. So that's just a floating point precision issue. This should be 1. We can see how similar the user at position 1 is to us. Somewhat similar. Basically, a similarity of 1 means you have the exact same tastes and preferences, and then the lower the similarity measure, the lower the similarity metric, the less similar your tastes in books are. All right, so we'll now import numpy as mp, and we will find the indices of the users who are most similar to us. And that's what this numpy arg partition function does. We're passing in -15. So what we're going to find are the 15 users who have the most similar taste to us. And these are their indices in the matrix. So these are the 15 users who are most similar to us in terms of book tastes. All right, so now what we can do is we can find their user IDs. Right now we only have their positions. Arg partition finds the positions of the highest values. So we found the positions of the highest values in this similarity matrix. Now what we need to find is their user IDs. So what we'll say is interactions user ID, user index, because you'll remember that our user index column was the position of the user. So we'll say, hey, find all of the rows in interactions where the user index is in our indices. And then make a copy to avoid the setting copy with warning error. All right, so we can take a look at similar users now. And actually, let's take ourselves out of this. Remember, we have the user ID -1. So we'll just take ourselves out so we're not getting book recommendations from ourselves, because that would be strange. So now let's take a look at similar users. And we can see we now have 38,000 rows of potential books that we might want to read. These are all book recommendations. And these are based on the users who are most similar to us. So what we can do now is actually figure out how many times each book appeared in these recommendations. So what we'll say is, hey, book recs equals similar users dot group by. We'll group it by book ID. And then we will take the rating column and we'll aggregate it. So we'll count up how many times each book appeared, and then we will find the mean rating. So if all of our similar users read a book and they all rated it a 1, we probably don't want to read that book. So the average rating helps us figure out, do we actually want to read this book or not? So let's take a look at book recs. All right, so this is now, each row is a specific book, and then the count tells us how many times that book was recommended to us, and the mean tells us what the score was, how those users rated the book. Now, this isn't super useful to us because we don't yet have the book titles. So this is where that book's titles file comes in handy. So we'll read in bookstitles.json, and then we will ensure that the book ID is a string. As we've been ensuring elsewhere. All right, now we can actually merge our two data sets to get the book titles into our recommendations. So we'll go ahead and say, hey, let's merge on books titles. If you're familiar with SQL joins, this merge should look familiar. We're going to do an inner join, and we're going to merge on book ID. All right, so let's take a look at book recs now. All right, so we can see we now have the same columns we had before. We have book ID, we have count, we have mean, but now we also have the titles and the URLs and the cover images, which is a little bit nicer than just seeing a book ID. We can now tell which books have been recommended to us. All right, the next thing we need to do is rank these. So we have 23,000 recommendations. We need to figure out which recommendations are the most relevant to us. So to do that, we'll first create an adjusted count, which is a count but normalized for how many times the book appeared among people like us relative to other people. As I type this out, you'll hopefully see what that means. So ratings is the number of times the book was rated across all of Goodreads. So what this does is it says, hey, we want books that were really popular among users like us, but weren't as popular among users not like us. So we want to find the books that are specific to us and users like us. We don't just want the books that are super popular for everyone, like Harry Potter. We want books that are specifically tailored to our taste. So that's what this adjusted count helps us do. That should be book recs. Then we'll create a score. So this is just a score indicating how much we might like each book. And we'll use the mean. So if you remember, that is the mean, the average rating from all of the users like us who have read the same book. And we'll multiply that by the count. So how many times the book was recommended. Then what we'll do is we'll take out any books we've already read. And we will do that in a couple of ways. So first, we'll take out any book where the book ID matches an ID of a book we've already read. And the second thing we'll do is we'll take out any books where the title matches a book we've already read. And the reason why we want to take out on the title too is some books have duplicate IDs. It's not the cleanest data. So if we just only take out books based on this, some books will still remain that we've already read. And we want to try to get rid of as many books that we've already read as possible. So you notice we have this mod title column. Basically, we will convert the titles in the books that we liked to the same format, and we'll remove any books from these recommendations that match the title of the books we liked. So we'll create a mod title column. And we'll say, okay, my books, take the title of the books that we liked. Remember, that's the my books data frame. And we'll replace first any non A through Z, 0 through 9 space character. So this just means we'll take out any character that doesn't fall in this set of characters. And we're using a regular expression. So that's the first thing we'll do. Then we'll go ahead and lowercase. So we can run that. And the next thing we'll do is we'll just replace any sequences of spaces. So there are sometimes, we talked about this in the last video when we also did this, this replacement, but there's sometimes in this data where a book title will have multiple spaces in a row. So we just want to replace multiple spaces in a row with a single space. All right, so that should be our going ahead and putting the books we read, the titles, into the same format as this mod title column in book recs. And then we'll go ahead and just say, okay, let's take out anything in our recommendations where the mod title fits into into the books we already read. And that's what this isin function does. Method. All right, so what this is doing is it's saying, look at the book recommendations. The tilde means take anything that doesn't fall into this set. And this set is take anything where the title in the recommendation is the same as the title in the books we liked. So it's essentially saying remove any of the books we liked that are in our recommendations, that we've already read and already liked from our recommendations, because we don't want to see a book if we already read it. All right, and then let's go ahead and remove anything that didn't appear, that appeared less than twice or less in our recommendations. So this is saying at least 3 users who are similar to us had to read the book and like it in order for us to, had to read it actually, period, in order for us to put it in our recommendations. Okay, then let's add an additional filter here for the mean. So we want to make sure we only find books where our mean rating is greater than a certain amount, in this case 4. We don't want books that were rated too lowly. All right, now we can create our top recommendations. So we'll go ahead and sort based on our score. This basically sorts the data frame based on the score, and we'll say ascending equals false. All right, and then we can take a look at our top recommendations. Okay, so this shows you the books that we might like the most. This is not very easy to see though, and there are a couple of things we can do to make this look a little bit nicer. So we can actually, and you saw this in the last video, we can actually create functions to style columns in pandas data frames. So what we can do is we can actually create clickable links, and we can render the cover images. So we'll go ahead and write this function, which will give us clickable links to Goodreads for each book, which is very cool. And we'll end that tag. All right, and then the other function we can write is to render the cover image. So don't worry too much if you don't know HTML. Basically, what you can do is, using a pandas styler method, you can style each column using HTML. So when you render the data frame, actually I don't need the link here. And you will see this once I finish writing this code. So let's go ahead and run these functions. And then what we can do is we can say toprecs.style.format. So format the URL column using make clickable. And then format the cover image column using show image. All right, so let's run that. And what we see now is our books are nicely formatted. All right, and these are the books that have been recommended for me. And we can see the adjusted count and score column if we want to figure out how highly they are recommended. So this is great. We've come really far here. We've gone from our early data sets and some book preferences we had all the way through to recommendations for next books we might want to read, which is fantastic. Now, if you wanted to tweak this, there are a few things you could do. So there's a few parameters here that you could try to modify and just see if they give you better recommendations or not. So one easy one is this filtered users. Let me find it. So you can try filtering users less or more to try to get more users in your set. It'll take longer to run, but you might get better recommendations. Like if, for example, you change this to 50 to find users who overlapped with fewer of your books. There is a way to scrape Goodreads and to get more books into your liked books. So you could try that if you want to give more data to base recommendations on. You can also try to find more similar users to you. So we only took the top 15. You could take 100 or 200 or even more users if you wanted. You could also try to weight the recommendations by how similar the user was to you. So the more similar someone is to you, the more highly you could value their recommendations. So that's another thing you could try. And you could tweak some of the details in this formula. So you could try adjusting how you compute the score and which books you remove from this set. And those should all improve the quality of your recommendations. So those are some good steps you can take to improve this next time. But I do hope you enjoyed this project walkthrough and that you did end up building the project. If you do end up building it, please share. I'd love to see that in the YouTube comments. All right, thank you so much.